Simplifying complex fractions. So a complex rational expression or a complex fraction are rational expressions, fractions, whose numerator, denominator, or both contain one or more rational expressions. There are two methods that can be used when simplifying complex fractions, but we're actually going to do just one, just so that you don't have to learn 20 million things. So basically, a complex fraction is one fraction on top of another fraction. And so the way that we're going to solve this, to simplify a complex fraction, you're going to add or subtract fractions in the numerator and or denominator so that the numerator is a single fraction and the denominator is a single fraction. So before you can start this method, the very first step is to get one fraction over one fraction. That's the number one thing. Once you do that, you're going to perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator of the complex fraction. Basically, you're doing keep, change, flip at this point. And then you're going to write your expression in simplest form. In other words, everything needs to be prime. Alright, so look at this one. We have 1 over 10x over 2 over 5x squared. So you have one fraction. Here's your numerator as a fraction. And notice this line is thick. That's your actual division bar. Divided by, here's your denominator as a fraction. Okay, so remember step number one, and it needs to be one fraction set over another fraction. So step number one is done for us. So at this point, all we need to do is rewrite the division problem to make it look like something that we're used to. So we have 1 over 10x divided by 2 over 5x squared. So from here, you guys know what to do. You're going to keep the first one as is, change the division and multiplication and flip that second fraction. From here, you know that we're multiplying and we can reduce within the problem. We can reduce the 5 and the 10 and the x's because we all have monomials, or because we have monomials here. Or we can multiply straight across and then reduce, and I think that's what I'm going to do. So 1 times 5x squared is 5x squared, and 10x times 2 is going to be 20x. Now to reduce, the 5 will go to 24 times, and this x will cancel out one of those. So on the top, all I have left is 1x, and on the bottom, all I have left is a 4, so I have x over 4. So the difference in this problem and the next one is that in the first problem, in the first example, we have one fraction over one fraction, so we don't have to worry about step number one. But in this problem, look at what I have. I have two fractions, because I can put that 2 over 1, right? Over two separate fractions, because again, I can put that over 1. So the first thing I need to do is I need to get one fraction over one fraction, which means I'm going to add x over 2 plus 2 over 1. Now you know in order to add fractions I have to find a common denominator. So the common denominator is going to be 2. So I'm going to multiply the top and the bottom of this fraction over here on the right by 2 because the first fraction has the denominator that I need, so I don't need to mess with it. But the next one is going to turn into 4 over 2. And then from there, let's do this. From there, I'm going to combine the tops, they're not like terms though, over that common denominator. So now I've made the top into one fraction. Let's do the same thing on the bottom. Common denominator again is going to be 2. So I'm going to have x over 2 minus 4 over 2. Then put them over that common denominator of 2, and so I'm going to have x minus 4 over 2. So now that I have one fraction over one fraction, I can write this problem as a normal division problem, what I'm used to seeing. And then from there, we're going to keep, change, and flip. From there, I can reduce the 2's, and that's it because my groups are not the same. And so I have x plus 4 over x minus 4. And that's your answer. Alright, so let's see if we can find some shortcuts in the process. So again, first, right off the bat, I have two fractions over two fractions. No good. So I've got to find a common denominator. My common denominator for the top is going to be 3y. So I'm going to multiply, 3y squared. Common denominator is going to be 3y squared. Okay, so to make this y squared go to 3y squared, I need to multiply the top and the bottom by 3. So that's going to go to 3. And here I need the y squared. So that's going to be 2y squared. Alright, let's go to the bottom. Common denominator is going to be 6y. So here I'm going to multiply by 6 over 6, and here I'm going to multiply by y over y. So I'm going to have 6 over 6y minus 5y over 6y. Alright, so let's make one fraction. So I'm going to have 3 plus 2y squared over 3y squared over 6 minus 5y over 6y. So now that I have one fraction over one fraction, you can write it out as a division problem like what you're used to, but I'm going to introduce something to you. I'm going to show you something that we can do. So you know that you're going to keep the first fraction as is, and then you're going to change division to multiplication, and you're going to flip that bottom fraction. So you have 6y over 6 minus 5y. Okay, so I just took out the step of rewriting the division problem, and I went ahead and kept the top as is, changed the division bar to multiplication, and then flipped that bottom fraction. And so now I have groups here, so that's not going to reduce, but the 3 will go into 6 2 times, and this y will cancel this y. One of those y's, I guess I should say. And so on top, I have 2 times 3 plus 2y squared, and on bottom I have y times 6 minus 5y. And everything's prime, so that's going to be your answer. Alright, let's try this one. I have one fraction on top, but I have two fractions on the bottom, so I need to fix that. So I'm going to leave the top alone. But on bottom, I've got to have a common denominator of y. So I'm going to have x over y plus 2y over y, multiplying the top and the bottom by y. So I have x plus 1 over y over x plus 2y over y. And so now I'm going to show you another thing. So what I like to do is I like to do skin over guts. So what we're going to do is we're going to put the outside, which is our skin, together over our guts, which is going to be the inside. So we're going to have y over x plus 2y. From here, the y's will cancel out and you get x plus 1 over x plus 2y. Now that's the shortest way of doing it. That's all the shortcuts that I can give you. But if you don't want to take the shortcuts, then don't take them. Then just write out all the steps.